Now, how do we quantitate an equilibrium? We quantitate equilibrium with a constant called an equilibrium constant. Okay, capital K is K. How do you compute it? If we have a reaction that looks like this, A, B gives rise to C, D, or for example 2A plus 3B in equilibrium with 1D and 4C, something like this. So these small case letters are coefficients and capital K's are chemicals. Then your equilibrium constant, let's say for this case K would be, and we'll call it Kc, because we are saying that Kc is equal to concentration of D, as in molarity of D, multiplied by molarity of C raised to 4, and this 4 is coming from here, divided by concentration of A square multiplied by concentration of B cube. And all these powers come from the coefficients. Okay, so we work to get the equilibrium constants for the reaction that we have seen in the last video. Carbon monoxide plus water in equilibrium with carbon dioxide and hydrogen. Kc would be H2 concentration multiplied by CO2 concentration divided by CO concentration and H2O concentration, and we are assuming that these are all gases. Okay, now there are a couple of things that you have to keep in mind. One, make sure you balance the equation, because you have to get the coefficients right. 2, equilibrium constant expression will have concentrations and or pressures, okay, of gases and aqueous ions. In other words, we had a reaction like this, say KClO3 solid in equilibrium with KClO solid and oxygen gas. Normally, you would think that from the equation, you would think that Kc would be equal to KClO concentration multiplied by O2 concentration divided by KClO3. That's what you would think. But remember, these both are solids. So we can have only gases and aqueous solutions. So Kc for this would be just concentration of oxygen. Equilibrium will be equal to concentration of oxygens, which is why I am erasing the KClO3 and KClO concentration. So Kc would be just the concentration of oxygen. So another example, nitrogen plus 3 hydrogens are in equilibrium with 2 ammonia, all of them being gases. Kc would be concentration of ammonia square divided by concentration of nitrogen and concentration of hydrogen cube. Now this is Kc, concentration equilibrium constant. If the data was pressures, then Kp would be pressure of ammonia square pressure of nitrogen multiplied by pressure of hydrogen cube. Now remember, very important thing. The third important thing is that these concentrations and pressures are equilibrium concentrations and pressures. Equilibrium parameters. They are the concentrations and pressures at equilibrium. If you consider this reaction N2 plus 3H2 in equilibrium with 2NH3, all of them being gases, okay, say you started the reaction with 0.5 molar nitrogen and say 2.0 hydrogen. Of course, at the beginning there will be 0 ammonia, and say at equilibrium there is 0.1 molar nitrogen present and about 0.8 molar hydrogen present, and 0.4 mole of ammonia has been produced. So these are the parameters at equilibrium. Then your Kc would be 0.4 square divided by 0.1 multiplied by 0.8 cube, and when you work on the division you will get the value for Kc. Now Kc, since it's a ratio, no units.